This is part 2 of the lesson 7.1 tutorial on the slope-intercept form. We will be covering examples 3, 4, and 5 in the notes package, as well as looking at the key ideas of the section. In example 3, we have a word problem where we need to convert the equation given into the slope-intercept form. So let's look at our problem. We have Students' Council rents a portable dunk tank as a fundraising activity. Students pay for the chance to hit the target with a ball and dunk a teacher into the tank of water. The relationship between the number of balls thrown, x, and the profit, y, in dollars is represented by the equation 3x minus 2y minus 600 equals 0. Rewrite the equation into the slope-intercept form, or y equals mx plus b. When we do this, if we have to get our equation in y equals mx plus b form, we need to move everything except the y variable to one side of the equation. So to rearrange this equation, the first thing we need to do is move this negative 600 by adding 600 to both sides. That will give us 3x minus 2y is equal to 600. Then what we do is we need to move the 3x term. It's positive, so we're going to subtract it from both sides. Minus 3x from both sides, and you're left with negative 2y. Notice that the 2y term was subtracted, so it becomes negative. And 600 minus 3x, or minus 3x, plus 600. The last step we need to do is divide to get the y completely by itself is we're going to divide both sides by negative 2. And when we do that, we need to divide every term by negative 2. When you're multiplying or dividing, you have to do every term. And that leaves us with y by itself on the left side. And then we have negative 3 over negative 2, which gives us just positive 3 over 2, x. Negative divided by negative is a positive. And 600 divided by negative 2 is negative 300. So this is our y equals mx plus b form of the equation. Part B asks us to identify the slope of the line, and what does it represent? Well, we can get the slope out of the equation that we just rearranged. The slope is the coefficient of the x variable. So the slope, or m, is equal to 3 over 2. It represents the slope of the line, or the rate of change. And it means that for every $1.50, or it costs $1.50 per ball, the slope is positive because there's money coming in. So for part C, we want to state what the y-intercept is and what it represents. We can also identify the y-intercept from the slope-intercept form in part A. The y-intercept is the constant in the equation, or the number written by itself without a variable. B represents the y-intercept, and it would be equal to negative 300 in this problem. It would represent the starting cost of the dunk tank, which, because it's negative, it means they had to go into the hole a little bit to get the dunk tank. So they had to pay $300 initially for the tank. Once they've made $300, they would be breaking even, and then after that, they would be making money. The break-even point is the point at which the money raised equals the money spent. How many balls must the students sell to reach the break-even point? That is, what is the value of x when y is equal to 0? So what we can do here is sub in 0 for the y value and solve for x. So we'd have 0 equals 3 over 2x minus 300. To solve for x, we would add 300 to both sides, and then we would have 300 is equal to 3 over 2x. Now this is the same thing now x is being multiplied by 3 and divided by 2. We can also write that like this. 300 is equal to 3x over 2. Now to get x by itself, you can multiply both sides by 2. So you get 600 equals 3x, and then divide both sides by 3 to get x by itself. And your x is equal to 600 divided by 3, which is 200. And what does that mean? That means that they would have to sell 300 balls for the dunk tank in order to break even or earn the $300 back that they spent to rent the tank initially. In example 4, we look at solving for a parameter. A parameter is a variable that has a constant value in a particular equation. So usually if we're solving for a parameter, we're solving for a missing variable like b or m. In part A, we are wanting to solve for the value of b given the equation y equals 3x plus b, and that the point -4, 6 is on the line. Another way this question can be asked is, what is the y-intercept of a line that goes through the point -4, 6 and has an equation of y equals 3x plus b? So let's write down the information that we are given. We are given that the equation is 3x plus b equal to y, and we're also given the point -4, 6. Now this can be any point on the line, but what this point gives us is an x value and a y value that make the equation true. So we're going to go ahead and sub those x and y values into the equation. So the y value is 6, we'll replace y with 6. And our x value was -4, so we replace x with -4 and plus b. Now, we actually have one variable left after we've solved in or subbed in the x and the y. We have b left, so we can solve for a variable if we only have one to solve for. So now we can solve for b, so we're going to multiply the 3 times -4, which gives us -12 plus b. And to get b by itself, we're going to add 12 to both sides. And we get that b is equal to 6 plus 12, which is 18. Now, that's the missing value from the original equation. So if we go back to writing down the original equation, we would have y equals 3x and then plus the b value, which was 18. So that would be the equation of the line that also passes through the point -4, 6. The line has a slope of 3 and a y-intercept of 18. Let's look at a different example where the m value is missing this time. So w is equal to m times t plus 10. And we're given the point 5, 19. That, again, is a value on the line. Now, our x variable in this question is actually now t, our independent variable. So in our coordinate, the first value is going to be t, and the second value is going to be represented by w, just like it would be x and y in the previous equation. Once we sub in 5 for t and w is 19, we get an equation where only m is left as a variable, and so then we can solve for it. If I'm going to rewrite that equation, that I could say 19 is equal to 5m plus 10, because m times 5 and 5 times m are really the same thing. Those are equal. So if I just come over to the right side, 19 equals 5m plus 10, and I solve for m, the first thing I need to do is subtract 10 from both sides. So I get 9 is equal to 5m. And then divide both sides by 5. So my answer is, for the slope, m is equal to 9 over 5. So that'd be like the rise is 9 and the run is 5 between any 2 points. When you rewrite your equation, you would have w is equal to 9 over 5t plus 10. In part C of this example, we are asked in the equation w equals mt plus 10, what is t when w equals 100? And then verify or check your answer. We have to use the equation that we just found. W equals 9 over 5t plus 10. Now we're told that w is equal to 100, so we can sub that in for w. 100 is equal to 9 over 5t plus 10, and we have to solve for t. So the first thing we're going to do is isolate the t term by subtracting 10 from both sides. You get 90 is equal to 9 over 5t. And just like the previous example, in example 2, when you have 9 over 5t, it's the same as saying 9 times t over 5. To isolate t now, we can multiply both sides by 5, and then we would get 450 is equal to 9t, then divide both sides by 9, and t is equal to 50, when w was equal to 100. To check or verify your answer, you would sub 50 in for t and 100 in for w and solve the left side and the right side to make sure they were equal. Using this table of values for example 5, we are going to sketch a graph of the data, find out the slope of the line and what does it represent, determine the value of the parameter b and what does it represent, write the equation in terms of pressure and depth in meters in the slope-intercept form, and determining the depth of the water when the pressure is at a certain value. To create the graph of the data, we plot the points in the table on a chart on our graph, where water depth in meters is on the horizontal axis, or the d-axis, and the pressure in kilopascals is along the vertical axis, or the p-axis. Once you plot those points and join them with a line, that will show you the pressure of the submarine as compared to the depth of the water. So in part B, we need to determine the ratio of the vertical change to the horizontal change to find the slope. We're going to use the slope formula that we used in chapter 6 for m is equal to y2 minus y1 over x2 minus x1. And we need 2 points on the line. We're going to use the first point from the table and the last point from the table to get the best approximation. So subbing in your numbers, we have 850 minus 100 divided by 75 minus 0. This gives us 750 over 75, which is equal to 10. And the units on that would be kilopascals per meter. What does that represent? Well, it represents that there's 10 kilopascals pressure change for every meter change in depth. The parameter b represents the y-intercept, which is equal to 100. The air pressure is 100 kilopascals at the surface of the water when the depth is 0. So our b value is equal to 100. That is the y-intercept of the graph. For part D, substitute m equals 10 and b equals 100 into the y equals mx plus b form to write the equation in the slope-intercept form. So we will have y is equal to 10 times x plus 100. And if we are using d for depth and p for pressure, would give us this equation in terms of their variables. So the pressure would be equal to 10 times the depth plus 100. Finally, in part E of this example, we want to solve for d when the pressure is equal to 109,300. So we sub 109,300 into our formula for p. We have to solve for d now. So we're going to subtract 100 from both sides, and we're left with 10d on the right side and 109,200 on the left side. Finally, divide both sides by 10, and your depth is equal to 10,920 meters when the pressure is 109,300 kilopascals. So, in summary, for lesson 7.1, slope-intercept form of a line, we looked at the equation of the line in the y equals mx plus b form, where m is the slope of the line and b is the y-intercept. We can use this equation to identify the slope or y-intercept of the line, and also to draw the graph of the line by starting at the y-intercept and using the slope to go up or down the line to the next point. We can convert to other forms of equations of the line, solve for an unknown parameter, and solve a problem that is modeled by the line.